Welcome back to part 2 of the Introduction to Making Schematics and PCBs with KiCad. In this episode, we're going to explain how the workflow works in KiCad and specifically how to capture a schematic. That means how to draw our schematic in the computer. So the first thing I need to do is open KiCad. Now, if you have a desktop icon, you can click on that. For my students, it's saved in a shared drive, the R drive. So go down here to the File Explorer. Scroll down to the Robotics Shared R drive. Within that folder, there's a KiCad folder. Click on that and then scroll down until you see the shortcut for KiCad. Double-click on that to open the KiCad program. When KiCad first opens, this is the Project Manager window. This manages all of the different programs in the KiCad suite. So you have the schematic editor, the symbol editor if you want to edit or create your own symbols, the PCB editor to lay out the printed circuit board, footprint editor if you need to change the size of components or create your own custom components, and then the Gerber viewer is to view the final files before you print them or send them to a board house to be printed. And then there's some other tools for images to put logos on a board, calculator for different electronics engineering calculator if you need it. And then over on this window, the project files window, it shows recent projects you've been working on. For my students, before you create a new blank project, go into the R drive, go down to the KiCad folder, and then create a folder with your name in it. So click on the new folder, and then with your name, then when you go to the KiCad Project Manager window, click on Create a New Blank Project or File New Project. Same thing. It'll ask you where you want to save it. Navigate to the R drive, the KiCad folder within the R drive, and then your folder. Then name the file something that relates to the schematic that you're working on. So for our example, this is going to be a surface mount device, adjustable LED. And it'll show up with the new project in the projects window. And the next thing you need to do is click on the schematic editor. It opens up a new page. Think of it as like your desk. You've got a sheet of paper and you're going to work on sketching your schematic. We need to put the information about this schematic into this corner. So double click on that somewhere in that box, and then you can select the issue date. We'll just push that button to put today's date in. We could say it's revision 1, change that later if we need to. Give it a title. We're going to say this is a SMD adjustable LED circuit. For the company, I always put the author. So I'll put my name in there. And if you want to put a comment about what the purpose of the circuit is, it's up to you. Then click OK. You can use the scroll wheel on your mouse to zoom in. Click and hold the center scroll wheel and you can move around the paper. Scroll back out. And wherever you are at, if you scroll, it'll scroll from that area. So the way KiCad works is across the top are tools that will help you with the workflow of your project. We're already in the schematic editor. We can open the symbol editor to create, delete, or edit symbols. You can go through the symbol libraries if you need, create, delete, and edit footprints there. Then we have a reference designator, so we can make sure all of our components have a reference number so that the schematic knows we haven't forgotten anything. This is one of the most useful things we'll get to is perform the electrical rules check. We can double check to make sure that this schematic would actually work, that it's not going to violate any rules. And eventually we get over to open the PCB in the board editor. So after we've designed our schematic, then we will open the PCB editor and lay out the traces, the tracks, the components on the PCB board. On the right side, these are the tools we're going to use to lay out our schematic. All of these are to help us lay out our schematic. On the left side is the grid, so we can snap things to the right locations. We can display it in inches or millimeters. At the bottom of the page it shows our X and Y coordinates, and as we move our cursor around it changes the XY coordinates, our grid size and unit of measure in millimeters. So now that we've set our page, hit the save icon. Make sure you save often. If you want to save different versions of it, so in case something goes wrong, you can revert to an older version. That's always a safe idea as well. All right, now we're going to take our original schematic and build it in the computer. So I'm going to go to the symbol first, First time you do this, it'll load the symbol libraries and load the footprint libraries, and this may take a while depending on how fast your computer is. Alright, and there's our symbols that we're allowed. Type in your symbol, so I'm going to type battery. We want a multiple cell battery or a single cell battery. If we're going to do a coin cell battery, then I'll type single cell battery. And here's my symbol. It's kind of small, so you can use that scroll wheel to zoom in. So I will place that on the sheet. It's highlighted, and if I just hit another place on the sheet, it'll load up the symbol library again for me. This time I want a resistor. Lots of different types of resistors. We're going to scroll down until we find a resistor US symbol. You can either double click on it or click OK. Some hotkeys that will make things go real quickly for you. On the keyboard, while you have your symbol highlighted, hit the R button and it rotates it. So I'm going to rotate that symbol and click to place it. Move to a new location. Click again with my mouse and it opens up the symbol editor again. I'm going to type a potentiometer. I want the US symbol for a potentiometer. Double click on that. And again, I'm going to use the hotkey R to rotate that. Going to scroll my mouse wheel to kind of zoom in with that. Click somewhere else on the sheet, and again, it opens up. I'm going to type in LED. Light emitting diode. Shows a symbol for it here. I'm going to double click on that. I want to rotate that as well, so hotkey R. And I'll place that there on the circuit. That's all the components I have. Now, if I just click somewhere, it'll open up the symbol editor or the symbol choosing window again. So I don't want to do that. So right click on it and hit cancel. Or if a symbol is highlighted, you can go up and click on the cursor arrow and it'll deselect that. Now I want to scroll down to where it says add a wire. I'm going to pick a wire. Start with the battery and then move over, click it, and it connects to the resistor. Then click on that end and click to the arrow in the potentiometer and it connects the wires. If you click anywhere on the sheet, it puts in a corner. So there's my schematic. Then again, click on the cursor arrow, select items, and it deselects the wire. Now I want to go through and make sure all my symbols have the correct values. To select the values of the components, double click on the component and it comes up with a symbol properties window. There's only one resistor, it's going to be labeled R1. When I click on the value, I can change this value. I'm going to put 220. I want a 220 ohm resistor. Now for footprint, you can do these later, but I'd recommend doing them now. If you associate the footprints with these schematic symbols to start with, you have much fewer problems later on down the line. So a footprint is the physical size and dimensions of the component that's going to go on your printed circuit board. So if you click on this library over here, it opens up the footprint library. I can type in the filter that I want a resistor. The two main categories are SMD, that stands for surface mount device, or THT for through-hole technology. We're going to use all surface mount resistors. The kinds that I already have are a 1206. So scroll down until you find R1206 or 3216 metric. The window shows a preview of what the footprint looks like. That's the one I want, so I'm going to double click on that and it adds that footprint in. Now for a data sheet, that's if you have a supplier, a company that you buy components from, they can provide information about that component. Probably the two most common big suppliers of electronic components are Mouser and DigiKey. You can go to either one of their websites. I use Mouser a lot, so I'll go there this time. This is their opening window at Mouser.com. I've created an account, so you can go over here to sign into your account if you want. I've already signed in. I've placed all these components in a project. You can create new projects. I call my project SMD Labs. So I have quite a few surface mount device components already in here. If you don't have a project list already, search for it by the keyword or part number up here. I'm just going to put SMD resistor 220. And it comes up with lots of results. Thick film resistors. I'll click on that one. You have all kinds of options you can apply filters to. I want a 220 ohm resistor, so I'm going to scroll down until I get 220 and then apply that filter. When you scroll down, I can sort by price in ascending order. If I want a certain package type, case code, I can scroll over, and the case code in inches is that 1206, so I can also apply that filter. All of these resistors come with a data sheet. Also, specifications are listed here, so it tells you the resistance, the power rating. It's a 1/4 watt resistor, 5% tolerance. So I'm going to click on the data sheet to show you how you do this. This shows all these resistors, has all kinds of information about tolerances, size, layout. So here's the web address. You can copy that web address, go back to your schematic, and then just paste it in that data sheet window. So if you ever need to come back and refer to that information, it's easy and quick to find. Then when you're finished, click OK. And resistor 1 has got the value of 220 ohms now. And we're going to go to double click on the potentiometer. We're going to change this to 50K ohms. Load a footprint, a surface mount potentiometer. Here's the one I ordered from Mouser. It's a Borns TC33X. Again, if I look down at the series, TC33X, that's the one I've already ordered. So when I go back to my schematic, I want to search for Borns. Here's all the Borns. TC33X, right there. That's the one I want to associate the footprint with. And if I want, I can go back, copy the data sheet, and put it in there. Click OK. My potentiometer now has a footprint associated with it. The LED, if I go back to my project list, the LED is right here from Worth Electronic. There's the LEDs. Tells me it's red LED. The package case code is 0603 or 1608 metric. So I want to make sure I know that package size code so that I get the right footprint. Again, I could copy the data sheet, double click on my component. Footprint was there it is, 0603 or 1608 metric. That's the one I want. Double click that. It adds the footprint in the Symbol Properties window. The last thing is a coin cell battery. It's a 3-volt battery. So here's a 2032 battery holder. You see these are very similar. I like the one with the larger tabs. So one for the positive, one for negative. So I'm going to double click on that. So I copied the data sheet from the Mouser website, and now all my components are finished. That's my schematic layout. And now I'm finished with schematic capture. Thank you for joining me for part 2 of Introduction to Making Schematics and PCBs with KiCad. In this part, we learned how to capture our schematic in KiCad. So now it's in the computer. Join me for part 3, where we'll go over the electrical rules check to make sure everything's good, and then open PCB New to lay out the PCB. See you in part 3.